So this video is going to go over molar mass again, but it's also going to talk about how we're going to use these molar mass in calculations. So in the last video, I left off with calcium phosphate, okay? And what you have to do is realize that phosphate, there are two of them. So that means there are two phosphoruses, and then you have a total of 8 oxygens. So that's where these numbers came from. So if you look up calcium, again, calcium is over here. It is about 40.1, okay? Phosphorus is about 31, I rounded up, okay? And then for oxygen, again, is 16. So what I did was I took 3 times 40.1, 2 times 31, 8 times 16, and I got about 310.3. So again, with all of our molar masses, we're going to use a digit after the decimals, how we're going to do it. So for every 1 mole of calcium phosphate, I have 310.3 grams. So that's nice and all, but what are we going to use it for? Well, we're going to use it to do a series of calculations. And the first calculation we're going to do is to grams. So I'm going to title each one of these calculations the following way. So these are going to be called moles to grams calculation, moles to grams calculations. So how many grams are in 3.4 moles of water? Okay, so what we're going to use here is essentially the molar mass of our water. So we already calculated that up here, okay? So we know for every 1 mole of water, we have 18 grams. So this is a calculation where we're going to use a proportion. So this is why we did the Corny activity, is for you to kind of get introduced to what we call proportions. So we know that for every 1 mole of water, we have 18 grams. Okay, so we're going to set this up in a proportion. And when I set up a proportion, it doesn't really matter what I put on top versus the other. But for my calculations, I'm always going to put grams over moles. And that's because that's the unit of molar mass. So that's why I'm going to keep using it. So I don't know the grams. So I'm going to put grams here as X. And then the moles are going to go on the bottom here, 3.4. Okay, so you're always going to put over here on the left, proportion is going to be what's given in the problem. So I do not know the grams and I have the moles. So I'm going to put it up here. Again, if you put the moles on top and grams on the bottom, it doesn't matter. As long as you put the grams and the moles on the same side, equal sign, the moles have to be on the bottom, grams have to be on the top, just be the same on both sides. So I know for water, for every 18 grams, I have 1 mole. So again, we're going to cross multiply, okay? So we have 3.4 times 18, so X is equal to about 61 grams. And for sig figs, we are going with 2, because whatever I start with is what I end with. I do not look at the molar mass for sig figs. I always go with what I start with is what I'm going to end with. So why don't you try this one? Okay, how many grams are in 10.9 moles of KCl? So what you have to do first is you have to find the molar mass of KCl first. You have to add that up from your periodic table. So I'm going to pause the video, and when I come back, I'm going to show you the answer. So check your answer here. Potassium chloride. If you look up potassium, it's 39.1. Chlorine is 35.5. When you add it together, you get 74.6 grams per mole. That's the molar mass of potassium chloride. So I'm going to set up my proportion. So I'm going to put grams on the top, moles on the bottom. Grams, I do not know. That's what I'm looking for. It's X. I'm given 10.9 moles, so I put it on the bottom. My molar mass is then next door. So I have 74.6 for every 1 mole. So for potassium chloride, that's going to be my go-to. So I should cross multiply. So 10.9 times 74.6, and I get 813 grams. I have 3 sig figs in my answer because I start with 3 sigs. So the 10.9 is 3 sig figs. So if I could go from moles to grams, I could also go the opposite way, okay? I could go from grams to moles. So how many moles are in 110.9 grams of ammonium chloride, So again, for each one of these calculations, I have to find the molar mass first. So I have to add up the nitrogen, the 4 hydrogens, and the chlorine. So nitrogen, when you look it up on the periodic table, again, this is where we get all of our information, that is 14. So I have 14 grams plus, I have 4 times, hydrogen is always 1, and then we've already seen chlorine. Okay, again, chlorine is right here. We're going to round it to 35.5, 35.5, just so you agree with my answer keys. Okay, if you take it out more, that's okay, but it's just not going to agree with my answer sometimes. So you get 53.5 grams per mole for ammonium chloride. So I'm going to set up my proportions, but this time I have grams and I'm going to moles. So I'm going to put the grams on the top again. The one on the left is always going to be what you're given. And then on the bottom, in this case, is the moles. This is what I'm trying to find. So that's my X. So then my molar mass again is 53.5 grams for every 1 mole. So now the cross multiplication is a little bit more tricky. Okay, so I have that times X and that times that. So I am taking this number and dividing it by 53.5 to get X by itself. So X comes out to be about 2.073 moles. And again, I have 4 digits in my answer because I have 4 digits here in my problem. So the only difference with all of these problems is the fact that you're going to be given a different formula and a different amount of grams, but the same setup is exactly the same. So again, you could put moles over grams, that doesn't matter, but I always like to do grams over moles because that is the unit for molarity. So for molar mass. So how many moles are 52.3 grams of CH4, which is methane? So see if you could do this problem, pause the video, and then I'm going to show the answer. So you should have ended up with 3.27 moles. Again, what's given in the problem, 52.3 over X moles is equal to 16 over 1 mole. Cross multiply, so you're taking 52.3 and dividing it by 16 to get X by itself, you get 3.27.